Try something. Here we go. Get a little stir bar going here. Add some deionized water. It's always tough to pour this in without spilling anything. There we go. Okay. That looks kind of cool. All right, let's add some universal indicator. Trying something a little new here. I don't know if it's going to work or not. Give it a good old squirt. You see that yellow color develop. I'm used to seeing that because I know that deionized water exposed to the atmosphere is going to have some carbon dioxide dissolved in it. And carbon dioxide, when it's in water, it's slightly acidic. Add a little bit more here. There we go. Looks pretty, doesn't it? Very pretty. Okay, now what I'm going to do is I'm going to add some milk of magnesia. Here we go, this stuff here. Milk of magnesia. Milk of magnesia contains magnesium hydroxide, which is alkaline. Basic. Let's see what happens. Come on. Here we go. All right, in goes the milk of magnesia. That looked cool, man. And a blue color develops, and that's because, looks pretty. That's because the milk of magnesia contains magnesium hydroxide, and a little bit of the magnesium hydroxide dissolves. And that forms free hydroxide ions, which is basic. All right, now what we're going to do, but notice it's like cloudy, right? Let's see if I can get that. Yeah, you can see it's kind of violet. So here's our pH values. You can see, you know, when I first put it in, it was pH 6. It was yellow color. When I added the milk of magnesia, I mean, you test for yourself. That looks violet to me. You might think it's like, I don't know, pH 9 or 10. Hello there, Carmela. Hello there, Cassiandro and Andy. That's right, Kino, making some hydroxide ion. What I did, okay, so what I did is I added to this flask, I added some water and universal indicator. And universal indicator shows these colors at different pH values. To my eye, it looks like it's pH 10, which is quite basic. Some folks might think it's pH 9. Is this drinkable? Not now that I've added the universal indicator. One of the dyes in universal indicator is a laxative. Okay, now what I'm going to do is I'm going to add a drop of hydrochloric acid. I mean, that's what this stuff is used for, right? This stuff is used to neutralize acid in your stomach when you got an upset stomach. So I'm going to add some hydrochloric acid, same acids found in your stomach. Let's add a few drops here. Let's go like 3. And of course it turns red because I've added acid, but there's still some undissolved magnesium hydroxide left that is neutralizing the acid. And you can see as it neutralizes the acid, it pulls the pH to neutral. And actually now we're at pH 8, aren't we? We're going to let this run a little bit because I can still see there's still some solid magnesium hydroxide in here. And as that continues to dissolve, maybe it's going to go to pH 9 or 10. I don't know. I don't know if it's going to get there or not. I think we're stuck at pH 8. Pretty cool, huh, Kino? Hello there, Funkers. Thank you there, Nation Broskies. Okay, I'm now going to add another drop. I guess it's slightly getting a little bit more blue. But it takes a little while for the rest of it to go. So I'm going to add another drop of acid. So in it goes. You can see it lower the pH. Come on, Kino, put in the balanced chemical equation. You're gonna need 2 hydrochloric acids. Hey, hello there, Eddie Almond. All right, I'm gonna do 3 drops this time. 1, 2, 3. You can see it go down to pH 3. Yeah, pH 3. And then as the magnesium hydroxide, the solid magnesium hydroxide that's in there reacts with the acid, it pulls it back to neutral, and then it's going to go to, you know, as the magnesium hydroxide dissolves, it'll go slightly more basic. So we're like an aqua color now. Native blood. Come on, man. Yeah, I think we're at pH 8 again, yeah? So again, here, I'll write the chemical equation down. Let's write it down so you can see it. Got to get to my chalkboard here. Let's add another drop and watch it go, though, while I'm writing this down so you have something to watch. There you go. Kino has entered the chat. Kino has written, if you look there, the chemical equation that describes what's happening. The magnesium hydroxide that's solid, that's in here, it reacts with the hydrochloric acid, and it neutralizes it. Definitely neutralizes it. Pretty cool, huh? And now you can see the pH is, you know, it's like 8, but it's starting to head toward 9. It's getting more dark blue as I let the, you know, as I let the reaction continue to go. I'm going to go ahead and add 3 drops of hydrochloric acid, and that's going to put a lot of acid in the system. So now we're at pH 3. But as the solid magnesium hydroxide reacts with the hydrochloric acid, it neutralizes it and pulls it back up to pH 7. It's been neutralized, and now some of the magnesium hydroxide, the solid magnesium hydroxide that's in there, will continue to dissolve, and that's going to pull the pH probably to like pH 8. Yep, we're about pH 8 now. Malik boy, we're seeing neutralization right now. What reaction is bromine and calcium? That would, you know, bromine, Br2 plus calcium metal. That's going to form some calcium bromide for sure. Beautiful reaction happening here, though. Really kind of pretty. You might also notice it's getting less cloudy, and that's because the solid magnesium hydroxide that's in here, as it reacts, it dissolves. It is cool, Eddie Almond. All right, let's add 2 drops. So this will be over. You know, when it's over, it'll look transparent. That's when all the magnesium hydroxide has dissolved. Painkiller, I do some reactions with deuterium oxide. You can check that out on my channel. I've got some videos that show some of the chemistry of deuterium oxide. Can you tell it's getting a little more transparent? Can you see that? Indeed, Kino. Thank you there, Ajith MB. I don't have any of that, Malik boy. Channel 8. No, these aren't illegal. Okay, so Ajith asks, why is it turning colors so fast? I have added to the flask universal indicator, which displays these colors depending upon pH. When I add acid, that's going to add protons to the solution. Thank you there, Syad. It does look like the Hulk, man. So I'm going to add some hydrochloric acid. That's going to add protons, free protons to solution, and so that's going to turn the color red very rapidly. Now, slowly over time, the solid magnesium hydroxide that's in here will react with the added protons, and it should pull the pH back high if there's any more solid left. There may not be. It's looking like it might be transparent, although, yep, it's turned orange, so there's some solid left. Yep, so the pH is still rising. The pH is still rising, so there is some solid magnesium hydroxide left. Yeah, that's right. It's a neutralization reaction. Yeah, the whirlpool is happening because here in the look down here at the bottom, there's a little magnet inside the inside the flask, and then I turn this on. It's like a magnetic fan here, magnetic fan blades, and when the magnetic fan blade spins, it spins that little magnet. Mike, I'm actually doing a titration right now. Thank you there, Biko. You're doing acids and bases, and you're writing a physics exam on Friday. Hey, Shamori, what's going on? We got a member in the chat. Good to see you. Thanks for being a member. I think this might be completely neutralized. Thank you there, NKM. Appreciate the subscription. I think these next few drops might completely dissolve the magnesium hydroxide. Victor, ask me your questions. I'll do the best I can, while I'm chatting during the live. Well, Shamori, I hope your work is productive today. What's going on, Lord Dustin? All the way from Texas. Yeah, you can see, right? Now you can see it's red and transparent, which means I have completely neutralized all of the magnesium hydroxide. No, it's not dangerous to breathe. Not at all. So I'm going to add some more, okay? We're going to add some more milk of magnesia, okay? We're going to add more milk of magnesia to the flask. Please notice that these are the acids and bases I'm using right now are hydrochloric acid and magnesium hydroxide. So these are the colors you're going to see. Now you're going to watch me add some magnesium hydroxide. So let's go ahead and add this. Yeah, right now it's like pH 2 or 3. Here we go. Here we go. So here's my milk of magnesia. It's solid, which is why it's white. It's solid suspended in liquid. So I'm going to go ahead and squirt this in here. In goes the magnesium hydroxide. You can see everything cloud up because I've added solid particles. So it's a bunch of solid particles of magnesium hydroxide. And that's going to neutralize the acid that I've added. And you can see the pH go up. Ha! Come on, we're at pH 6. pH 6. And when it hits green, that's going to be pH 7. So we're at roughly pH 7 right now. And as the magnesium hydroxide continues to dissolve, we might get that pH up to around 8 or 9. Interesting, Shamori. So you can't even get like, come on. Well, magnesium metal, I would imagine, but you can't even get like milk of magnesia, Shamori? That's hard to believe. Boy, it's taken a bit for some of that magnesium hydroxide to dissolve to make it basic, but we can definitely see it's green now, right? And that's starting to fade to a darker. Interesting. So you're at pH 7. We've neutralized it. I want to wait till this gets to a blue color. We'll see if it goes there. Interesting. I don't have any of that, Pickle Rick. I don't have any uranium either. Yeah, I would think you could get some from, interesting. So can you tell it's sort of fading to a more aqua color? Adiyaman, I'd love to. It'd be a lot of fun. I just don't, let's just say I don't have the funds. I don't have any of that, Germany. I don't have any of that. All right, let's go ahead. Let's add some acid. Let's add the hydrochloric acid. Eric, I don't have a whole lot of stuff in here in the experiments that I'm doing. Got a cool way to remember Arrhenius versus Bronsted in terms of the acids and bases definitions. Oh, you can tell. Look, it's getting to like pH 8 now. Yeah? It takes a while for it to dissolve for sure. Okay, here we go. I'm going to now add some hydrochloric acid. It's the same acid that's found in your stomach. Here we go. Let's add her in. Let's go 3 drops. 1, 2, 3. You can see the red color develop because I've added a lot of protons. Those protons are free in solution, and it will slowly react with the solid magnesium hydroxide that's in there, and that'll neutralize the acid. So you can see we started with a red color. Now we're at like pH 4. That orange color should fade to like yellow and then green. Oh, I don't think we're going to explode. I don't have any sulfuric acid with me. Yep, we're already at yellow. So long, Shamori. Thank you there, Lord Dustin. Painkiller. I imagine it would go a little slower. I need to try that. That'd be interesting. Yeah, yes, Moez. Mercury can dissolve in certain acids. Kaufman, what's going on? From my undergraduate years? Is that right? Come on, baby. Let me know. Thanks, Germany, for the sub. No, what's changing the color, Pickle Rip? Come on, David. That's awesome, man. I hope things are well with you. I'm here in my basement doing experiments. Thank you there, Germany. Shanto, that sounds pretty good to me. You got a 93 in biology. I got a buddy here from my undergraduate days. If I remember correctly, David, you were a bio major. Forgive me if I don't remember correctly. Things get hard to remember as we age. Thank you there, Danielle. I appreciate it. Danny's coming in right after doing a titration lab. So long, Adiaman. Okay, here we go. Martha, what it is I have some milk of magnesia in here. The milk of magnesia has you can probably see a little bit. There's little tiny solid particles of magnesium hydroxide in here, and they slowly dissolve. They really slowly dissolve. All right, and as they dissolve, they make the solution basic. And you can see here that the solution is like pH 8, which is slightly basic, okay? Matching the colors. Now what I like to do is I'm going to add some hydrochloric acid up here at the top. It's the same acid that's found in your stomach, and that's going to add a lot of protons. It's going to drop the pH. Look at that. We went from like 8 to 3. That's a change in the acidity of 100,000 times. But you'll notice that red color, it's starting already to fade to orange, so our pH has risen to 4. Peroxide's not going to do much, Germany. And as we continue to wait, that may slowly fade to other colors. I don't know much about that, Eric. Can you show your all experiment? I'm sorry, I don't understand the question. It's me. Darren, I'd have to quit the live and go. I don't actually have any orange juice in my fridge. Look at that. We're at yellow, so that's pH 6. That is pH 6. I don't have any orange juice. As we continue to watch this. Hey, thank you there, Sandile. That's oh, forgive me. Is it? Thank you there, Mr. Green. Pickle Rick from Texas. I've seen Pickle Rick from time to time in my life. It's good to see you. I'm not making a time machine. Come on, man. Adia, thank you for the suggestion. I'm going to make a short of this, okay? Let's go, Vortex. Come on, man. We're at pH 7, says Darren. You got it. What reaction's taking place? Here, I'll write it out for you. If someone else can drop it in the chat if you'd like. So here is the reaction. Yeah, I'll show you the test materials. The magnesium, it's magnesium hydroxide, and that's going to go to dissolved magnesium chloride. Okay. Martha, I'm loving it. So here, just forgive me for a second. Here we go. Oh, it's going to be a little hard to get this in. Let me just back up the camera just a second so you can see the reaction. So here's the reaction that's going on up at the top. Magnesium hydroxide, that's what's supplied by the milk of magnesia. It is a solid, which is why it has a slight cloudy color, and you can see little solid particles floating around in here. When I add hydrochloric acid to the system, what basically happens at first is there's an excess of hydrochloric acid, which is why the pH drops. This is a solid. This is dissolved, and it's the dissolved portion that drives the pH. Now, slowly over time, this reaction happens. The hydrochloric acid neutralizes the magnesium hydroxide, and you form this stuff which dissolves, and this has no effect on the pH. It also forms water, so it gets neutralized, and that's why the pH rises as the reaction goes on. Now, over time, the magnesium hydroxide, any of that's left, will dissolve, and that's what makes it slightly basic. And you can tell we're up to pH 8 now, me jabbering on, as I was jabbering on. some of that solid continued to dissolve, and that dissolved solid, you know, it forms hydroxide ion, which makes the pH higher. Here we go, it's me. What I'm using is milk of magnesia, water in a flask, universal indicator, let's give it the color. And then I add drops of 20% by weight. That's this stuff, hydrochloric acid. Here, let's add it here. So that's all the stuff I'm doing. You wouldn't want to drink this. It would ruin your afternoon. One of the dyes in universal indicators, phenolphthalein, which used to be the main ingredient in X-Lax. Here we go. Here we go. In goes the acid. 1, 2, 3 drops. Of course, the acid dissolves, and that drives the pH low. Let's see what happens to the pH, okay? Thank you there, Ada. Stefan, what we're doing is we are looking at the reaction between milk of magnesia and stomach acid, basically, is what we're doing. Have you considered making a video on naturally occurring pH indicators? I've already done that, Collis Bufflin. Check out some of my lives. I do that quite a bit. They're a lot of fun. Jorgen, that's up to you, man. I'm not drinking that. One of the dyes in there is a laxative. Eric, indeed. Indeed. Thank you, Carlos. Thanks for commenting and hanging out. It's called a neutralization reaction. Thank you there, Random. $10 if I finish the flask. Damien, I think you mean finish it by drinking it? Yeah, it's not going to happen, man. You know, it's just not happening. But hey, thanks for the offer. Can I throw something in the acidic liquid? Yeah, I agree, Danielle. So you want me to throw something in there while the liquid's acidic? Well, it is acidic right now, yeah? So it's pH 6, which is just slightly acidic. Now we're going 100. Yeah, I'm not doing it, guys. I'm not doing it. Yep. All right. So it's slightly acidic. I'm now going to add some more milk of magnesia, okay? Yeah, Eric, I've done that too, man. It's no fun, is it? It's no fun getting those hydrogen peroxide burns. What chemical reactions would you need to make this non-toxic and drinkable? Callus, I just wouldn't want, you can, I mean, people drink milk of magnesia, and there's water. You just don't want to have the indicator in there. So, Pickle Rick, different, so in goes the milk of magnesia. Pickle Rick, different regions of the body have different pH values. So, you know, like in the stomach, the pH is quite low. And in the intestines, I think portions of the intestines, the pH is basic a little bit. Your blood, though, is very well regulated at like pH 7.4. What happened if I dropped a cookie in there? I don't think it was peroxide that Michael Jackson did. So yeah, our pH is like 7. It's higher than 7 now. It's approaching pH 8. Yeah. So we're definitely basic. So now what I'll do is I'll add some acid, and that'll form a lot of protons, dissolved protons. In they go. Here we go. Bunch of dissolved protons. 3 drops. Shifts to red. And then really slowly over time, the dissolved magnesium hydroxide will react with those protons. And you'll watch the pH. See, we went from pH 3 to 4. As that dissolved magnesium hydroxide slowly reacts. Now we're up to pH 6. Oh, nothing. I don't have any with me right now. When protons drop, where do they go? Asked Dens. So, okay. Tough question. I don't have any liquid nitrogen. I'm not making it go boom. I apologize. So, protons to a chemist is an H plus ion. We write it like that, H plus. And when the protons go into the solution, they react with water. So they react with H2O like this. and they form something called the hydronium ion, which is H3O plus. H3O plus. And this H3O plus then reacts with the dyes and makes the dyes change color. So, Angela, what I'm doing right now is I have a flask that has some universal indicator. Universal indicator changes color depending upon pH. So we can see right now that the pH in this mixture is like 7 or 8 by comparing it to the colors. So it's neutral to slightly basic. I'm not making anything go boom today, Ensar. Okay. And in this flask, I've added some magnesium hydroxide from milk of magnesia. Yeah, if you hate chemistry, this is not the channel for you, buddy. All right. Milk of magnesia is a base, which is going to make this go alkaline or basic. But it dissolves very slowly. You can see there's like a solid that's in here, and you can even see the solid particles if you look closely, and they dissolve real slowly. That's right, Martha. I do some other experiments. The logo on the flask, here, we'll show you. There you go. You guys want to see the logo? I turn it this way because I figure it looks better without the logo, but I can show it if you wish. Anyway, boy, that's irritating me, that little sound there. Let's get it rolling again. Okay, so we've got the base in here. All right, and now what I'm going to do is I'm going to add some acid. Okay, hydrochloric acid, the same acid that's found in your stomach. We're at pH 8. Watch what happens when I drip in the hydrochloric acid. Man, the pH drops like crazy. We went from pH 8 to pH 3. But the solid magnesium hydroxide that's in here will slowly react with the acid that I added and neutralize it. We can watch that happen. What's going on, Agent? The base pantomath is magnesium hydroxide. Nothing, I don't have any sand to add. So you can see our pH is now up to 6. Is it just, there we go, I finally got it. The pH is up to 6. And it should completely neutralize it. At some point, we're going to get to pH 7. What's up, Mutanamir? Anarag, hello? Sorry, hey, Jammy, I apologize. I'm trying to... Do you get darker red if I dump acid in? Yeah, if I dump enough in. What's up there, Aim? Martha, I don't know about doing... Yeah, I might be able to do that if I get in the lab. If I keep adding things to it, the volume doesn't seem to increase, asked Denny. That's because I'm just adding tiny little drops, right? And so, let's turn this around and let's keep track. So you can kind of keep track of how much is in there. I'll bet I started with the volume about right here. Sorry, I can't add sand. I don't have any. Okay, here we go. I'm going to add a few drops of hydrochloric acid. Yeah, I'm going to, I'll be banning you to keep spamming. Yep. We'll get rid of you real quick. So we go to red. I've added, thank you there, Denny. I've added the acid. And the pH is red. And if there's any magnesium hydroxide left, which I can tell there is because it's gone from red to orange. No, Wizard, it's not. And as the magnesium hydroxide continues to react, it should, now we're up to pH 6. And as it slowly reacts, it may go all the way to neutral. Sure, Montague, yeah. I mean, go ahead. This chemistry is well known. Go for it. I do have a video where I react sand with magnesium. And I find that chemistry really interesting. You form stuff called magnesium nitride. Sorry, Lily Bell, I don't have any of that. No orange juice. Roblox, you mean will it change again if I add more acid? Indeed it will. But you can tell I'm starting to react away all of the magnesium hydroxide. I'm starting to see it's getting transparent. And when that happens, that means a lot of the magnesium hydroxide has reacted away. Hello there, Kazi. All right, so let's go ahead and add some acid. I'm going to add some hydrochloric acid, the same acid that's found in your stomach, except this stuff is like a lot more concentrated. And you can see the red color go. Yeah, we could add some water. By the way, the acid that I'm adding is like 80% water. Very cool, Eric. I've done a video on sparklers. And what do you think happens if you stick a sparkler in liquid nitrogen? What do you think happens? Does it go out? Does it keep burning? And if it keeps burning, what happens? What forms? Is there any chemical that's formed? Check out my shorts videos. I've got a video on that. But Namir, you're right. The alkalinity increases because there's still magnesium hydroxide base in solution, and I keep adding the HCl until it stays just red, meaning there's no hydroxide that's left. That's correct, and you can tell that the magnesium hydroxide is being consumed as the transparency increases. No, Denny, it is not flammable, and Kazi, it is universal indicator. I've done some sugar rockets, Lord Dustin, and I've even done a Lego rocket. So I've done those. Yeah, I've done those on my channel. You can check those out. Sorry, Lily Bell, I don't have any liquid nitrogen. I apologize. Not today. So Roblox, hi Sci-Fi. What's causing the color is I've added universal indicator to this. Universal indicator is a substance that changes color depending upon whether it's in an acid or a base. So right now we can see we're at pH 6. I'm going to go ahead and add a bunch of acid here. 5 drops. Let's see what happens. Let's see if there's enough magnesium hydroxide in there to neutralize the acid. We're at red. We're at pH 3, 2, or 1 right now. I don't know if I've got enough magnesium hydroxide. Thank you there, Danielle. So yeah, it turns to red because you know, the acid I added lowers the pH, so we're down to pH 3. What's my favorite pH? I love the question, man. Yeah, I've done that, Eric. You can use potassium chlorate as the oxidizer. Hello there, Maddie. So what's my favorite pH, asks Callus. Everybody drop in the chat, what's your favorite pH? You know, the thing that immediately comes to mind for me is pH 7.4, because that's like the pH of human life, right? That's the pH of our blood. Denny, I don't think it does. Oh, you can see it's fading to orange. I can tell it's getting to orange, so there's a little bit of magnesium hydroxide left. But it's going really slow, so I'm gonna add another squirt. Me too, Sci-Fi. Stefan, why pH 3.5? Why is 3.5 your favorite? Yeah, pH 7. You're pretty comfortable. I don't know, man. If your blood gets to pH 7, you're a goner. Sorry, Eric. I'm gonna need a little more information. Gotcha. Nice, Stefan. All right, I'm gonna go ahead and add in another shot of magnesium hydroxide. Denny, it does at the beginning, and then it just takes so long for the magnesium hydroxide to dissolve that it's really tough to get back to violet again in this particular experiment. Yeah, I like that too. I like the color. I mean, if we're talking about which colors I like it when it goes rainbow, man. I like it when it's like full rainbow. You can see all the colors at once. That's really my favorite. Yeah, there's some of that stuff that goes on, Collis. Oh, nice. Thanks, Eric. Appreciate it. Yeah, we're doing it right now, EZBCLS. I have added the antacid. It's been added. And as that slowly dissolves, you'll notice the pH is rising. We're at pH 7. I'm going to wait till it gets like pH 8 or 9. Denny, that's a different experiment I do where the rainbow happens. It's a little tough to see in this experiment. It's just a different experiment I do where I get the rainbow to happen. I don't know how to do that. I mean, in theory I do, but practically is a different story, your daddy. So what is this? Is I've added an antacid to this flask. The antacid is milk of magnesia. It's a base, and you can tell the solution is slowly getting basic. It's like almost pH 8 as the milk of magnesia slowly dissolves. Okay. And then what I do, yeah, it is nice, isn't it, Roblox? I'm liking the cyan color as well. And then what I'll do is I'll add some acid. The acid I'm adding is the same acid that's found in your stomach. It's hydrochloric acid. And I'll add a few drops of that, and we'll just watch the magic happen. Here we go. In here at the top, 3 drops of the hydrochloric acid. Oh, we got a nice red color. Me too, Nawaz. Now, as the milk of magnesia that's present reacts with the acid that I added, it neutralizes it. So you can see, it's pretty. It's gone from pH 3 to like pH 6 or 7 at this point. No, Brian, the indicator dye, one of them's a laxative, so I'm not messing with that. Indeed, M. Kai, indeed. Thank you, LOL. Lilybell, the magnesium hydroxide does dissolve. I agree, Aim. Hey, thanks, Lord. Thanks for hanging out. Appreciate it. Here we go. Let's add a few more drops of the acid here, up here at the top. 1, 2, 3, 4, 5, 6. Let's see how long that takes to neutralize that. What's up, Sep? You could drink it, but I wouldn't recommend it because one of the dyes in there is a laxative. So, Homebro, what's going on is I've got some milk of magnesia in here, which is basic. And the milk of magnesia, I've also got acid in there, and the acid makes the pH drop. All right? So right now we can see the pH is like, 6 or 7. And that's because as the milk of magnesia slowly dissolves, it increases the pH. Thanks there, Home. All right. Now what I can do is I can add some acid that's going to cause the pH to drop. So I add like 3 drops. 1, 2, 3. So the pH drops. And the milk of magnesia will slowly react with the acid that I've added. And you'll watch it increases the pH. See, we're up at pH 5, pH 6. So that's what's going on. The acid that I'm adding is stomach acid, hydrochloric acid, same acid that's found in your stomach. It's just that this is like 1,000 times more concentrated. Hydrochloric acid, Shruti, HCl. That's what I'm adding. So here's the chemical reaction that's going on. Real quick, I'll show you. So it's this is milk of magnesia, MgOH, plus hydrochloric acid. It forms magnesium chloride that dissolves, MgCl2, and water. So that's what's going on. Oh, man, nice and green. I don't know, Denny. I think what would happen is YouTube would ban me, so... LOL, it wouldn't hurt my skin. You got it, Nawaz. Okay, I'm going to add some acid now. We're going to go ahead and add drops of acid. We'll watch the pH drop, of course. And then very slowly, the magnesium hydroxide should react with that. Sister, the stuff I'm using is not, it's not really that caustic. So, cool, Montague. MgCl2, isn't that acidic? Roblox, it is slightly. Slightly it is. That's correct. Cool, Montague. Drop the link for folks to see. What if we added ammonia? That's a good question. I don't have any down here. It would go basic. Things will go, ammonia's a base. All right. Let's add a little bit more. What milliliter is the endpoint typically for this experiment? Mudamir, that's going to depend on how much milk of magnesia I add. Obviously, the more milk of magnesia I add, the more acid I'm going to need to neutralize it. So yeah, you can see I've added some acid, and the milk of magnesia that's present is neutralizing that acid, and it's causing the color to change because the pH is going back up. Kind of cool, man. All right, well, I'm going to have to head out. I got to get ready. I'm going out to lunch with my wife. So she's going to be home pretty soon. I appreciate y'all hanging out here with me. Hey, Detonator, what's going on? It's good to hang out with you and look at some of the beauty of science. It's really easy to see. We did a little different experiment today. Hope you all enjoyed it. You got it, Brian. It looks like I... Thank you there, Denny. We added the acid one more time. Good to hang out with you. Consider subscribing if you haven't already. We're getting really close to 500,000 subscribers, folks. You might be part of the people who helped me get there. So thanks for hanging out and watching this YouTube live. And I hope you all have a great day and pay attention to the beauty that's around you, man. That scientific beauty, it's all over the place. Sunrises, sunsets, clouds in the sky, the rustling of the wind and the rivers. Thank you there, Dog Lover. Thank you, Brian, Detonator. Thank you there, too, Fanny. Appreciate it. So we'll see you next time, all right? Thanks for hanging out.